Welcome to the Deep Dive. This is where we grab your stack of sources, dig through them with you, and really pull out the most important knowledge, those key insights, and maybe some surprising facts too.
Exactly. Think of us as guides, helping you cut straight through to what really matters in the material you've brought us.
And today we're diving deep into a really complex topic, one that sits right at the crossroads of science, economics, policy, and, well, even ethics. Climate change.
It is a big one. We've got a significant stack of material here to guide us. It covers pretty much everything from the basic science to the impacts on people and the planet, the economic side of things, and of course, potential policy responses.
Yeah, we'll be drawing quite heavily from analyses like the Stern Review, which is very comprehensive, and also looking at perspectives on the ethical dimensions surrounding this whole challenge.
Our mission really is to unpack all these sources for you. We want to highlight the crucial facts, the connections you need to understand the core challenges, and maybe some of the potential pathways forward that are laid out in this material.
It's definitely complex, no doubt about it. But these sources do provide some pretty clear ways of framing the issue. So let's jump right in. Where should we start with all this?
Well, you have to start with the bedrock, right? The science itself. The sources we have present just an overwhelming body of evidence showing that the Earth's climate is changing, and changing rapidly.
Okay. And crucially,
They make it very clear that this change is primarily a direct result of human activities. Specifically, it's down to the increase in greenhouse gas concentrations in our atmosphere.
right. So what exactly are these human activities doing? How are they changing the atmosphere?
Fundamentally, they're altering its composition. The sources point out that since around 1750, the start of the industrial era, carbon dioxide concentrations, CO2, have shot up by just over a third.
A third? Wow. From what to what?
We went from about 280 parts per million ppm up to around 380 ppm when these sources were compiled. And that's a huge jump in a relatively short geological timescale.
It really is. Where's the bulk of that extra CO2 coming from?
Well, it's mainly from burning fossil fuels, coal, oil, gas for energy, for transport, but also significantly from deforestation and other big changes in how we use land.
And it's not just CO2, is it? There are other gases involved.
No, absolutely not. You've got accompanying rises in other key greenhouse gases. Methane, for example, and nitrous oxide. The sources often talk about the Kyoto greenhouse gases. Those are the main six covered by the Kyoto Protocol.
Right, so that's CO2, methane, nitrous oxide. What else?
And then the fluorinated gases. HFCs, PFCs, and SF6 sulfur hexafluoride. Those are potent, even if less voluminous than CO2 or methane.
Got it. So when you bundle the warming effect of all these human-caused gases together, what does the picture look like?
The material states that the total warming effect from all these human-emitted Kyoto gases is now equivalent to having about 430 ppm of just CO2. This measure is called CO2 equivalent, or CO2e.
430 ppm CO2e, and that number isn't standing still, I assume?
No, definitely not. It's rising. The sources say it's currently going up by about 2.3 ppm per year. That rate of increase is pretty substantial.
It feels substantial. How does this compare to, say, Earth's longer history? Is this unusual?
This is where the sources provide a fact that is, well, frankly, staggering. Current levels of greenhouse gases in the atmosphere are higher now than at any point in at least the last 650,000 years.
650,000 years. How do we even know that?
That's based on incredibly detailed analysis of ice cores drilled in places like Antarctica and Greenland. The trapped air bubbles in those cores give us a direct record of past atmospheric composition.
Wow. Okay, so unprecedented levels in a very long time. And these high levels are what amplify the natural greenhouse effect, right? Trapping more heat.
Exactly. These rising concentrations mean the atmosphere essentially holds on to more infrared radiation heat energy that would otherwise escape back into space. And this directly leads to the warming trend we're observing globally.
Okay, we understand the basic mechanism, the record gas levels. But what about the future? Is the science completely settled on exactly how much warming we'll get for a given amount of emissions?
That's a good question. The sources acknowledge that while the overall warming trend is undeniable, pinning down the precise amount of future warming for a specific emissions pathway is still an area of active research. There's a range of possibilities.
So there's uncertainty there.
Yes, but it's important how that uncertainty is treated. The material we have builds on earlier assessments, like the big IPCC reports. But newer studies cited here use more sophisticated methods, explicitly looking at risk and probability distributions.
And what do these newer analyses show?
They largely support the broad scientific consensus. But they also show a sizable probability, a non-negligible chance that the climate system's sensitivity to greenhouse gases is actually greater than previously thought.
Climate sensitivity.
Yeah.
That's how much the Earth warms for a certain increase in CO2.
Right.
Like a doubling.
Exactly. So for the same amount of greenhouse gas increase, there's a real possibility we could experience even more warming than some earlier models predicted. That's obviously quite concerning.
It is. Does anything else add to that potential for greater warming?
Yes, and this is fascinating and frankly adds another layer of complexity and potential risk. Scientists are studying feedbacks within the natural carbon cycle itself.
Feedbacks. What kind of things are we talking about?
Things like how warmer temperatures affect the ability of forests and soils to absorb CO2, or the potential for melting permafrost in the Arctic and Siberia to release vast amounts of stored methane and CO2.
So the Earth system itself could start adding to the warming as it gets warmer. Kind of a vicious cycle.
That's the potential risk, yes. These are often called positive feedbacks, and they could amplify the initial human-caused warming significantly. And while they're being intensely studied, these kinds of feedbacks are often not yet fully included in the standard climate models used for long-term projections.
Which means those projections might be underestimating the potential future warming.
It's a distinct possibility highlighted in the sources. And this isn't just about gradual, smooth warming either. The sources explicitly warn that the warming effect has the potential to trigger abrupt, large-scale, and potentially irreversible shifts in the climate system. Tipping points, essentially.
Okay, abrupt, large-scale, irreversible shifts. What are some examples mentioned in the material?
One major example discussed is a possible collapse or significant slowdown of the North Atlantic thermohaline circulation, the THC.
The THC, that's the big ocean current system, includes the Gulf Stream, right?
Yeah.
The one that keeps places like the UK and Northern Europe much warmer than they would be otherwise.
That's the one. It acts like a massive conveyor belt, moving warm surface water north and cold, deep water south. It's crucial for the regional climate of the North Atlantic and surrounding landmasses.
And climate change could disrupt that.
Well, the THC is driven by differences in water temperature and salinity. It could be weakened or potentially even shut down if the upper ocean warms too much, or if there's a large influx of fresh water from melting glaciers and ice sheets, or even just increased rainfall over the North Atlantic. Fresh water is less dense, you see, so it can cap the surface and prevent the sinking of cold, salty water that drives the whole circulation.
And these are exactly the kinds of changes a warming climate is expected to cause. Are the models predicting a collapse is imminent?
Well, no complex climate models currently predict a complete collapse of the THC within this century. Most models project a weakening, maybe by up to half by 2100 under higher emissions scenarios.
Okay, so a weakening, not a full collapse this century in most models.
However, the sources also mention a recent study based on direct ocean measurements, which suggested that part of the THC might have already weakened by as much as 30% in recent decades.
30% already? That sounds like a really significant change.
It is potentially very significant. Though the sources are careful here, they note it's not entirely clear yet whether this observed 30% weakening is part of a natural fluctuation, like a decades-long cycle, or if it truly represents the beginning of a long-term downward trend driven by climate change.
But it definitely raises a flag about these potential large-scale shifts maybe already being underway.
Absolutely. It underscores that potential. And speaking of water and melting ice, sea levels, that's another major consequence of warming that gets a lot of attention.
Right. What do the sources say about sea level rise? Is it happening now?
Oh, yes. Sea levels are already responding. They are currently rising globally at a rate of about 3 millimeters per year. And critically, that rate of rise appears to be accelerating.
3 millimeters a year doesn't sound like much, but I guess it adds up. What were the projections for the future?
The IPCC's third assessment report, which is referenced here, projected global average sea level rises of between 9 and 88 centimeters by the year 2100. That's quite a wide range, reflecting uncertainties, but even the lower end is significant.
Where does that rise come from, mainly?
It's primarily driven by two factors. First, thermal expansion. As ocean water warms, it expands, taking up more volume. Second, the melting of glaciers and ice caps on land, which adds water directly to the oceans.
Is that 9 to 88 centimeter range the end of the story for sea level rise by 2100?
Not at all. And this is a really crucial point the sources make. Because heat penetrates the vast, deep oceans incredibly slowly, sea levels will continue to rise substantially for centuries after greenhouse gas concentrations might stabilize, even if we stopped all emissions tomorrow.
So there's a long-term commitment already baked in.
A very significant one. One study cited estimates that our past emissions alone have already committed the world to somewhere between 0.1 and 1.1 meters of sea level rise over the next 400 years. That's roughly 1/3 of a foot to over 3.5 feet locked in, regardless of future actions.
Wow. So centuries of rise already determined. That really drives home the inertia in the climate system.
It really does highlight the long-term consequences. And beyond that gradual rise, there's the potential for very large multi-meter increases if major land-based ice sheets become unstable and start to melt irreversibly.
Which ones are the big concerns?
The sources specifically mention the Greenland ice sheet and the West Antarctic ice sheet. These are those potential large-scale, possibly irreversible tipping points we talked about earlier. Their collapse could lead to truly catastrophic levels of sea level rise globally.
Okay, so let's recap the science foundation here. Human activity causing record greenhouse gas levels, leading to rapid warming. A risk of even more warming than expected due to feedbacks. The potential for abrupt, maybe irreversible shifts like THC weakening or ice sheet collapse, and significant long-term sea level rise already committed, with potentially huge increases possible in the future.
That's a pretty accurate summary of the scientific picture presented in these sources. It sets the stage for why this matters so much.
Right. So if that's the science, let's unpack what this actually means for the world we live in, for people, for the planet. The sources make it really clear the impacts won't be felt evenly across the globe, will they?
No, that's probably one of the most critical insights regarding the impacts. Well, yes, a few areas in higher latitudes might see some minor initial benefits, maybe fewer deaths from cold snaps, perhaps very modest increases in some crop yields, but only up to maybe 2 or 3 degrees Celsius of warming.
But that's a very limited upside.
Extremely limited. The overwhelming picture painted by the sources is negative. Once warming goes beyond that moderate level, most countries, most regions will suffer heavily. And importantly, overall global economic growth is projected to be adversely affected.
And this is where it gets really concerning, maybe even alarming, when you dig into the specific impacts detailed in the sources. Let's start with the effects on people, particularly on poverty.
The material strongly emphasizes this point. The poorest countries, and within those countries, the poorest people, are especially vulnerable. They face a genuine risk of being trapped in, or pushed into, a downward spiral of increasing vulnerability and poverty. This is largely because climate impacts hit hardest in areas they are least equipped to cope with.
And there's some pretty stark numbers attached to that risk, aren't there?
There really are. The sources cite projections suggesting that by 2100, just looking at South Asia and Sub-Saharan Africa, anywhere from 145 million to 220 million additional people could fall below the $2 a day poverty line.
Additional people, purely because of climate change.
Yes, that estimate is based solely on the projected economic losses. The hit to GDP caused by climate impacts on things like agriculture, water availability, health, and so on.
That is just a staggering number of people potentially pushed into extreme poverty. And that must have knock-on effects, for example, on health outcomes.
Absolutely. Substantial negative health impacts are projected, despite those very localized potential minor benefits in colder regions. We can expect to see greater mortality and illness from direct effects like heat stress during heat waves, but also from the consequences of more frequent or intense droughts and floods.
What about diseases? Things spread by insects, for instance.
Vector-borne diseases, yes. Things like malaria and dengue fever are projected to become more widespread, especially if current disease control measures aren't dramatically scaled up and maintained effectively. The sources estimate that with just a 2-degree C rise in global average temperature, an extra 40 to 60 million people in Africa could be exposed to malaria.
And if warming goes higher?
At 3 to 4 degrees C warming, that figure could jump to 70 to 80 million additional people exposed in Africa alone. And critically, regions that were previously unaffected might simply lack the established public health infrastructure and experience to effectively control outbreaks of these diseases.
And for people already living in vulnerable situations like in urban slums, how are they affected?
For the poor, particularly those in informal settlements or slums, the risk of diseases like malaria or cholera is likely to increase significantly. This is often due to existing problems with poor sanitation and water quality, which are then made much worse by climate impacts like heat waves drying up clean sources or floods contaminating water supplies.
Is there an example of this in the sources?
Yes, there's a very vivid example cited from Delhi. During a major heat wave, cases of gastroenteritis reportedly increased by a dramatic 25%. Why? because slum dwellers facing water scarcity were forced to rely on contaminated water sources. It really brings home that direct, dangerous link between climate impacts and health risks for the most vulnerable populations.
It really does. What about the natural world itself? Ecosystems, biodiversity. What are the projected impacts there?
The sources indicate severe consequences for the natural world. Projections suggest that average global temperature increases of only 1 to 2 degrees C above pre-industrial levels could potentially commit somewhere between 15 and 40% of species globally to extinction in the long run.
15 to 40% of all species. That's an immense loss of biodiversity.
It is. And as temperatures rise higher, say above 2 to 3 degrees C later this century, the scale of potential loss increases dramatically. Thousands of species could be lost in critical biodiversity hotspots around the world. In some particularly vulnerable areas, projections suggest over 40% of endemic species, those found absolutely nowhere else on Earth, could face extinction.
It's devastating. Is it just land animals and plants? What about the oceans?
Marine ecosystems are also highly vulnerable. Coral bleaching is a major concern highlighted. This happens when heat stress causes corals to expel the tiny symbiotic algae they rely on for food and color. Increased ocean temperatures are making bleaching events more frequent and severe, leading to higher coral mortality and widespread damage to reef ecosystems. These reefs are vital nurseries for marine life and also provide crucial coastal protection for millions of people.
And the Arctic. That's warming faster, isn't it?
Yes, Arctic ecosystems are mentioned as particularly vulnerable. Temperatures there are rising at close to double the global average rate. This rapid warming drastically impacts unique species and habitats adapted to sea ice and extreme cold, like polar bears, seals, and numerous bird species.
Water is obviously fundamental. We talked about sea level rise, but what about freshwater resources on land? How is climate change expected to affect water availability?
Well, melting glaciers are a double-edged sword. Initially, they might increase river flows, but over the longer term, as they shrink and disappear, they will significantly reduce crucial dry season water supplies for a vast number of people. The sources estimate about 1/6 of the world's population.
Which regions are most dependent on glacier meltwater?
This predominantly affects regions heavily reliant on that meltwater for agriculture and drinking water during their dry seasons. We're talking about the Indian subcontinent, large parts of China, and the Andes region in South America. The loss of this reliable water source will be a major challenge.
And what about areas that don't rely on glaciers? Are they safe from water stress?
No, unfortunately not. Other regions are also projected to see reduced water availability due to changes in rainfall patterns and increased evaporation. For example, water availability and crop yields in areas like southern Europe and the Mediterranean are expected to decline significantly. One projection mentioned shows a 20% reduction with just a 2-degree C rise. Regions that are already facing water scarcity will likely face even more serious difficulties and rising costs to manage their limited water resources.
Let's shift to extreme weather events. We hear a lot about this. Are we seeing or expecting an increase in the intensity or frequency of things like hurricanes, floods, droughts?
The sources indicate that yes, a warmer, more energetic atmosphere and ocean system is likely to bring more intense extreme weather events. We're talking potentially stronger hurricanes and typhoons, more severe storms, bigger floods, longer and deeper droughts, and more extreme heat waves.
Is the science clearer on intensity increases than frequency changes?
Generally, yes. While changes to the overall number or exact location of these events can be complex and harder to pin down, there's growing evidence suggesting that increases in the intensity of many types of extreme events are already occurring and are projected to continue as the planet warms further.
Like hurricanes getting stronger.
Exactly. Some recent work cited in the sources suggests that the frequency of the very strongest hurricanes and typhoons categories 4 and 5 in the Atlantic Basin may have already doubled since the 1970s. The sources note this is potentially linked to rising sea surface temperatures. They do acknowledge it's still an active area of scientific debate, but the potential link and the observed trend are highlighted as a significant risk.
What about droughts and floods? How does warming affect those?
Well, it's somewhat paradoxical. Increased evaporation from warmer temperatures dries out soils faster, increasing drought risk in some regions or seasons. But a warmer atmosphere can also hold more moisture, meaning when it does rain, the rainfall can be more intense, increasing the risk of flooding in other areas or at other times, sometimes even in the same regions, swinging between extremes.
Is there a sense of how much drought risk could increase?
Yes, one quite striking study mentioned, apparently the first of its kind at the time, estimated that the fraction of global land area experiencing moderate drought at any given time could increase from about 25% currently to potentially 50% by the 2090s under a high emission scenario. Even more worryingly, the area in extreme drought could jump from around 3% now to possibly 30%.
A tenfold increase in extreme drought area. That's huge, with massive implications for farming, water, everything.
Immense implications. And it's not just rainfall. Changes in storm tracks matter too. In higher latitudes, for instance, some climate models show winter storm tracks shifting towards the poles. For countries like Australia, which rely heavily on those winter storms for their water supply, such a shift could lead to significant water scarcity problems down the line.
Okay, so we have rising sea levels, more intense floods, more intense droughts. This must point towards a massive potential for people being forced to move, for human displacement.
Absolutely. The combination of rising sea levels, inundating coastal areas, heavier floods damaging homes and infrastructure, and intense droughts making agriculture impossible could result in tens, potentially hundreds of millions more people being flooded each year, particularly with warming in the 3 to 4 degree C range.
Hundreds of millions. Are there estimates for permanent displacement?
Yes, one estimate cited in the material suggests that by the middle of this century, as many as 200 million people could become permanently displaced from their homes due to the impacts of climate change. Climate refugees, essentially, on an unprecedented scale.
200 million people. That number is hard to even comprehend. It implies truly immense social disruption. And all these physical and social impacts must come with significant economic costs.
They certainly do. The sources state that the costs just from the damage caused by extreme weather events alone could reach somewhere between 4.5% and 1% of world GDP per year by the middle of the century if warming continues on its current trajectory, and those costs would just keep rising.
And potentially higher costs for developed countries with more valuable infrastructure at risk.
Yes, exactly. For developed countries where there's often more high-value infrastructure concentrated in vulnerable areas like coastlines, higher temperatures and more intense extremes could lead to damages potentially costing several percent of their GDP in particularly bad years or regions.
Is there a sense of how costs scale with the intensity of storms, like hurricanes?
Yes, the sources note that hurricane damages, for example, don't just increase linearly with wind speed, they increase much faster, roughly scaling as the cube of wind speed, or perhaps even more.
The cube. So a small increase in wind speed means a much bigger increase in damage.
A much bigger increase. It means a relatively small 5–10% increase in average hurricane wind speed, which is within the range projected by some models, could potentially double the average annual damages from hurricanes. Using the U.S. as an example, that level of intensity increase could translate to average annual damages equivalent to about 0.13% of U.S. GDP year after year.
And that must have huge implications for industries like insurance.
Massive implications. If storm intensity increases by just 6%, which some models projected for a CO2 doubling or a 3 degrees C rise, this could force insurers to increase the capital they hold to cover potential losses by over 90% for U.S. hurricanes and 80% for Japanese typhoons. One estimate presented suggested this equates to needing an additional $76 billion in capital today just to cover that increased future risk.
So it's not just paying for damage after it happens, it's the massive financial burden of preparing for the increased risk itself. What about adapting infrastructure, like along coastlines?
Rising sea levels and stronger storms are going to demand huge investments in strengthening flood protection around ports and all the associated coastal industries, refineries, power plants, transport hubs that are often located right near the water.
So building higher seawalls, reinforcing structures.
Yes. But even then, multi-billion-dollar facilities like oil refineries, liquefied natural gas, LNG plants, or chemical factories might eventually need to be relocated further inland. That involves not just the massive capital cost of rebuilding, but also increased transport costs, potentially making imported goods more expensive for everyone. It could mean reversing decades of development patterns that favored coastal locations near deep-water ports.
And it's not just coastal areas. In colder regions, the warming itself can damage infrastructure.
That's right. Melting permafrost, permanently frozen ground in polar and subpolar regions, poses a significant risk to existing infrastructure. We're talking about oil and gas installations, pipelines, buildings, roads, and even major railways like Russia's Baikal-Amur Railway, which was built on permafrost. Stabilizing or relocating this infrastructure will require very expensive remedial investment.
And finally, these impacts, even the economic ones, don't just stay within the borders of the countries where they happen, do they?
No, the global economy is interconnected. The sources point out that the severe physical and social impacts hitting developing countries, which are often the most vulnerable, can have significant knock-on effects for developed economies too,
How so? Through what channels?
through disruptions to global supply chains and trade, for example. Think about raw materials or agricultural products sourced from affected regions. Also, through increased pressure from population movement and migration, potential impacts on international security and stability, and even the risk of financial contagion if major climate-related losses destabilize markets. Climate change will inevitably affect the prices and availability of goods traded internationally. So yeah, the overall picture of impacts painted in these sources is one of profound, widespread, and interconnected disruption. It affects everything from individual health and poverty, right up to natural ecosystems, water security, extreme weather patterns, human displacement, and the stability of the global economy.
It really is a complex web of cascading consequences.
Mhm.
Okay, so with these incredibly significant impacts laid out, it really prompts a deeper question, one that at least one of the sources we looked at delves into. How did we as a species, as humanity, actually get into this difficult situation in the first place? It explores the ethical dimension.
Yes, that ethical perspective provides really important context, doesn't it? The source suggests looking at this historically. For a long time, particularly in the Western world, as scientific and technological capabilities grew, there was often this prevailing mindset, this assumption that the Earth was essentially an endless resource, something put here purely for human use and benefit.
A resource to be dominated and exploited for our own ends.
Pretty much, yes. Progress itself was often conceived in terms of gaining mastery over nature, dominating other species, all for our own comfort and material advancement. This is fundamentally an anthropocentric viewpoint, placing human beings, human needs, desires, and values at the absolute center above all other considerations, including the health and integrity of the natural world itself.
So prioritizing human interests above all else, even the long-term health of the planet that sustains us.
Precisely. The source discusses how some environmental philosophers argue that we urgently need to shift away from this purely human-centered view towards a more non-anthropocentric or perhaps ecocentric attitude. Although they do acknowledge the complexity and ongoing debate around whether a completely non-anthropocentric viewpoint is fully achievable or even desirable for humans. But the core call is clear. We need to fundamentally rethink our values and our relationship with the non-human world.
And how does this historical anthropocentric view connect specifically to the climate change challenge we're facing now?
Well, the source highlights that ever since the Industrial Revolution kicked off, human societies, particularly in the developed world, have largely prioritized economic growth and the accumulation of material wealth above almost all other goals.
Pursuit of endless growth.
Yes, and this relentless focus on growth, the source argues, has led directly to actions like vast deforestation across the globe, clearing land for agriculture, timber, and development, and also to massive levels of pollution impacting land, sea, and air from industrial processes and waste.
And deforestation, as we discussed earlier, is a major contributor to the buildup of greenhouse gases in the atmosphere.
A very direct contributor. Trees are vital carbon sinks. They absorb CO2 from the atmosphere. Removing them on a vast scale, as has happened in many formerly forested regions, directly adds to the CO2 building up and warming the planet. The source explicitly connects this historical deforestation directly to our dominant economic choices and priorities.
So the argument is that our economic model itself and the consumption patterns it encourages are deeply intertwined with the environmental damage, including climate change, that we're now grappling with.
Absolutely. The source argues that much of modern life, especially in affluent developed nations, is built upon a level of consumption that comes at a direct cost to the natural world, causing significant damage to Earth's systems.
Which really raises some fundamental and difficult questions, doesn't it?
It certainly does. Questions posed by the source include: how can we realistically and significantly cut down on our consumption, especially material consumption? Do we need a fundamentally new ethical framework, perhaps a robust environmental ethics, to guide our actions and decisions in a way that is more sustainable and compatible with the long-term health of the planet?
And this historical approach This focus on growth and resource exploitation has had impacts beyond climate change, too, like on biodiversity.
Yes, the source explicitly links this historical trajectory, the focus on growth, coupled with deforestation, the industrialization of agriculture, pollution from mining and manufacturing directly to the extinction of numerous animal and plant species, and a significant ongoing reduction in global biodiversity. These severe environmental outcomes are presented not as accidents, but as direct consequences of our long-standing economic priorities and ethical choices, particularly that dominant anthropocentric worldview, and the prioritization of limitless economic expansion.
It really reframes the climate crisis, doesn't it? Not just as a technical problem of emissions and energy, or even just an economic problem of costs and benefits, but as a deep-seated ethical challenge, one rooted in how we've viewed our place on Earth for centuries.
It provides that crucial underlying context, suggesting that addressing climate change effectively might require more than just policy tweaks and new technologies. It might require a more fundamental shift in our values and worldview.
Okay, let's bring it back to the economics then, which many of the sources, especially the Stern Review, heavily emphasize. They frame climate change very clearly as an economic problem, one with potentially enormous costs associated with not acting, compared to the costs of taking action.
That's absolutely the central and arguably most powerful argument presented in much of this material, particularly Stern. The conclusion reached in the Stern Review is unambiguous and really quite stark. The risks of continuing on a business-as-usual path, basically, not taking strong, concerted action to reduce emissions, are incredibly serious.
How serious? What kind of scale are we talking about?
The potential disruption to global economic and social activity is described as being on a scale similar to the impacts of the Great Wars and the economic depression of the first half of the 20th century. That's the kind of magnitude of disruption they're talking about.
Wow. Comparing it to world wars and the Great Depression really puts the potential economic threat into perspective, doesn't it?
It absolutely does. It drives home the point that, according to this analysis, climate change isn't just some future environmental issue. It represents a fundamental threat to long-term economic stability and prosperity as we currently understand it. And critically, the changes triggered by unchecked warming could be difficult or perhaps impossible to reverse once they happen.
So massive potential costs from inaction. What about the costs of taking action? The costs of actually cutting emissions?
Well, in stark contrast to those potentially catastrophic costs of inaction, the sources present the costs of action, the costs of reducing greenhouse gas emissions significantly enough to avoid the worst impacts as being, relatively speaking, limited and manageable.
Limited compared to the alternative, you mean?
Precisely. The central estimate provided, particularly in the Stern Review, for the cost of mitigation, that is, the annual cost of implementing policies and technologies needed to reduce emissions sufficiently to stabilize greenhouse gas concentrations in the atmosphere at around 500 to 500 to 500 ppm CO2 equivalent, is estimated to be around 1% of global GDP each year.
Okay, so spending roughly 1% of global economic output annually, on average, to avoid those potentially massive, irreversible damages that could cost many times more.
That's exactly how the sources frame the choice. Mitigation isn't presented as an economic burden that hinders growth. Instead, it's framed as a highly productive investment, an investment we make today and in the coming decades to secure future prosperity and avoid incurring those potentially huge, irreversible costs down the road. And they back this up with detailed economic modeling work.
Right. What did that modeling actually indicate about the long-term costs of inaction, the business-as-usual scenario?
The modeling exercises described suggest that the combined risks and costs of climate change over the next 1 to 2 centuries, if we follow that business-as-usual path, could be equivalent to suffering an average reduction in global per capita consumption of at least 5%, starting now and continuing forever.
5% lower consumption permanently. That's a significant hit to living standards globally and perpetually.
It is. And the phrase now and forever really emphasizes that this isn't like a temporary recession you recover from. The damages from unchecked climate change could represent a permanent lowering of our potential economic output and standard of living compared to what could have been achieved in a stable climate.
And is that 5% figure the full picture?
The sources emphasize that this 5% estimate is likely conservative. Why? Because it primarily focuses on market impacts, things easily quantifiable in economic terms, and includes an allowance for the risk of catastrophic events. However, the cost would likely be much, much higher, potentially equivalent to a 20% cut in per capita consumption now and forever.
20%. That's 4 times higher. What else would need to be included to get to that figure?
That higher estimate comes into play if you more fully account for what the sources call non-market impacts. These are the hugely important consequences that aren't typically traded in markets or easily assigned a dollar value, but have immense human and ecological value.
Like what kind of impacts?
Things like the direct impact on human health and mortality, lives lost due to heat waves, floods, disease outbreaks. Also, the irreversible loss of ecosystems and biodiversity, the social disruption caused by mass migration, conflict over resources. These are profoundly costly impacts, even if they don't show up neatly in GDP figures. The higher estimate also factors in those climate carbon feedbacks we discussed earlier, which could amplify warming and, importantly, distributional issues.
Distributional issues meaning how the impacts fall unfairly.
Exactly. It means giving more weight to the fact that the costs of climate change fall disproportionately on the poor and vulnerable populations, both within and between countries, who contributed least to the problem and have the least capacity to cope. Accounting for these non-market impacts and these ethical weighting considerations, even with specific debatable value judgments, significantly increases the estimated cost of inaction, potentially up to that 20% equivalent loss in consumption.
So even the lower-end estimate of a 5% permanent loss is incredibly serious. But the true cost, when you try to factor in everything that matters beyond just market transactions, could be vastly higher.
That's the powerful economic message coming through from this material. The potential costs of inaction, including the very real risk of large-scale, irreversible, and potentially catastrophic damage, are presented as being so substantial that the estimated manageable cost of mitigation, that roughly 1% of GDP, is clearly warranted from an economic perspective.
So prompt and strong action isn't just environmentally necessary, it's framed here as essential economic policy for ensuring long-term prosperity and stability.
Absolutely. It fundamentally reframes investing in climate protection, not as a cost against the economy, but as a crucial investment in the economy's future health and resilience.
Okay, so if the science points to urgency, the impacts are severe, and the economics makes a strong case for action over inaction. How do we actually tackle this monumental challenge? Since climate change is inherently global, the response has to be international, and the sources say it needs a mix of strategies.
That's right. They broadly fall into two main categories: mitigation and adaptation.
Mitigation B.
Mitigation is all about reducing greenhouse gas emissions at their source, trying to limit the extent of future climate change.
And adaptation.
Adaptation is about coping with the impacts of climate change that are already happening or are now unavoidable, even with mitigation efforts. It's about building resilience and reducing vulnerability to the changes we can no longer prevent.
And the sources stress we need both, right?
Yeah.
They're not alternatives.
Exactly. They're presented as two essential pillars of a complete strategy. We need to mitigate as much as possible to avoid the unmanageable and adapt to the unavoidable.
Okay, let's dive into mitigation first, cutting those emissions. What kind of goals are discussed in the sources? How deep do the cuts need to be?
The sources talk about the overarching goal, enshrined in the UN Framework Convention, of stabilizing greenhouse gas concentrations in the atmosphere at a level that prevents dangerous anthropogenic interference with the climate system. The challenge, of course, is defining what level is dangerous.
So where does analysis like the Stern Review land on a target level?
Stern, specifically, focuses quite a bit on the implications of stabilizing concentrations in the range of 450 to 550 parts per million CO2 equivalent, ppm, CO2.
What's the thinking there?
It's presented as something of a balancing act. The review notes that aiming for stabilization much below 450 ppm CO2e might involve extremely high adjustment costs in the near term. It might be too economically disruptive to achieve that quickly. On the other hand, allowing concentrations to exceed 550 ppm substantially increases the risks of triggering those really severe and potentially irreversible impacts we talked about earlier: major ice sheet melt, large-scale ecosystem collapse, and so on.
So that 450-550 range is framed as a kind of safer corridor, balancing feasibility and risk based on the science at the time.
That seems to be the rationale presented, and achieving stabilization at any level, whether it's 450, 550, or something else, requires a fundamental long-term shift. Eventually, annual global emissions need to be brought down to the level that the Earth's natural systems, primarily oceans and land ecosystems, can absorb on an ongoing basis.
And what is that level? How much can the planet naturally absorb each year?
In the long term, the sources suggest this means getting net annual global emissions down below about 5 gigatons of CO2 equivalent per year. GTCO2e.
5 gigatons.
Yeah.
How does that compare to where we are now, or when these sources were compiled?
To put that in perspective, current global annual emissions are well over 50 GTCO2e. So achieving long-term stabilization requires an eventual reduction of more than 80% from current levels. It's a massive fundamental transformation of the global energy and land use systems.
An 80% cut eventually. That's huge.
Sure.
What kind of pathway is needed to get onto a trajectory for, say, stabilizing at 550 ppm by mid-century?
The required path depends heavily on when global emissions peak and how fast they fall afterwards. To stabilize around 550 ppm CO2e, the analysis suggests global emissions would need to peak within the next 10 to 20 years, so roughly between now and 2030, 2035, and then start falling consistently by at least 1 to 3% per year on average. This path would mean emissions in 2050 would need to be around 25% below today's levels.
Okay, peak in 10, 20 years, then a steady decline. What about stabilizing at the lower end, around 450 ppm?
To stabilize at 450 ppm CO2e, especially without overshooting that level significantly first, the required action is much more urgent and drastic. Emissions would need to peak much sooner, ideally within the next 10 years. And then they'd need to fall much more rapidly at an average rate of over 5% per year, reaching levels around 70% below current emissions by 2050.
Wow. That really starkly illustrates the cost of delaying action, doesn't it? The longer we wait to peak emissions, the steeper and more challenging the subsequent cuts have to be.
Exactly. Delaying significant global emissions reductions now effectively pushes a much larger burden onto future generations, requiring them to make extremely rapid, potentially much more costly and disruptive cuts later on.
So to make these cuts, we need to know where the emissions are actually coming from. What are the big sources we need to target?
The sources break down global emissions by sector. The biggest chunk, around 57%, comes from burning fossil fuels. That's for generating electricity and heat, powering transport, cars, trucks, planes, ships, running industrial processes, and heating and cooling buildings.
Okay, so energy and transport are huge. What about the rest?
A very substantial portion, estimated at about 41% of global emissions back in 2000, according to one figure presented, comes from agriculture and changes in land use. Critically, deforestation is the largest single component within that land use category.
41% from agriculture and land use. That's almost as much as fossil fuels. That seems higher than often discussed.
It is a very significant chunk, yes. The remaining slice, maybe around 2% or so, comes directly from industrial processes themselves, things like chemical reactions in cement production or the release of industrial gases.
And within that big agriculture and land use piece, it's not just deforestation, is it? What aspects of agriculture contribute?
No, agriculture itself is a major source, particularly of the non-CO2 greenhouse gases, methane, CH4, and nitrous oxide, N2O. These come from various farming activities.
Like what?
Things like the use of nitrogen-based fertilizers, which release N2O. Livestock, especially ruminants like cattle and sheep, produce large amounts of methane through digestion. Rice cultivation in flooded paddies releases methane, and the management of animal manure also releases both methane and nitrous oxide.
And where do most of these agricultural emissions come from?
The sources note that over half of these non-CO2 agricultural emissions actually originate in developing countries, reflecting the importance of agriculture in their economies and populations. Also, certain farming practices, like intensive tillage or plowing, can release significant amounts of carbon that was stored in the soil.
That's important context. And you mentioned buildings and industry earlier in the fossil fuel section. Do they have a bigger footprint than just their direct fuel burning?
Yes, that's a crucial point the sources make. While buildings and industries certainly have direct emissions from burning fuel on-site for heat or processes, they are also massive consumers of electricity and heat that is generated elsewhere, often from burning fossil fuels in power plants. So their total contribution to greenhouse gas emissions, when you account for that indirect energy use, is significantly larger than just their direct on-site emissions might suggest.
Right, so tackling emissions requires looking at the whole energy system supplying these sectors too. And achieving the scale of cuts needed sounds like it requires huge technological shifts across the board. How do the sources discuss the role of technology and innovation?
Innovation is presented as absolutely fundamental. It's seen as crucial for reducing the costs of developing and deploying the necessary low-carbon technologies across all these emitting sectors: power generation, transport, industry, buildings, agriculture. Cheaper low-carbon options make the transition much more feasible economically.
But do markets naturally provide enough innovation for something like climate change?
The sources argue pretty strongly that no, the market, left entirely to its own devices, tends to undersupply the level of innovation needed for a challenge like climate change. This is due to some classic market failures.
What kind of market failures are we talking about here in the context of clean technology innovation?
There are a couple of key ones highlighted. One is the problem of knowledge spillovers. When one company invests heavily in R&D and makes a breakthrough, the knowledge gain often spills over and benefits competitors and other industries too. The original innovator doesn't capture the full economic benefit of their investment, which discourages them from investing as much as would be socially optimal.
So the benefit to society is bigger than the benefit to the company doing the inventing.
Exactly. Another major issue is the very long-term nature of the primary benefit of climate change mitigation. The main payoff avoiding climate damages accrues over decades and centuries, far beyond the typical planning horizon for most private companies making investment decisions. Plus, the benefit is a global public good, making it hard for any single firm or even country to capture the returns.
So because the market underinvests in this kind of long-term public good innovation, there's a strong case for government involvement and support.
A very strong case, yes. The sources argue this clearly justifies government intervention to actively support both ends of the innovation spectrum. Research and development, R&D to create new options, and large-scale deployment to bring down the costs of existing and emerging technologies.
Why is deployment so important for innovation? Doesn't innovation happen in labs?
Deployment is critical because it drives cost reductions through learning by doing and economies of scale. The more you build and install things like solar panels or wind turbines or batteries, the better manufacturers get at making them, supply chains become more efficient, and the costs come down, often quite dramatically. The sources estimate that government incentives to encourage deployment may need to increase significantly, perhaps by 2 to 5 times worldwide, to really accelerate these cost reductions and speed up the uptake of clean technologies.
Looking back, has R&D spending on energy, particularly clean energy, been moving in the right direction historically?
Unfortunately, the sources note a worrying trend. Private sector energy R&D spending in the major developed OECD countries actually fell significantly from the late 1980s through to around 2003. The argument is that both public and private R&D spending needs to not only increase substantially, but also be much more strategically directed towards low-carbon energy options to drive the necessary technological transformation.
The sources included a figure, didn't they, showing the relative costs of different ways to cut emissions. Can you describe that concept?
Yes, there's reference to a conceptual figure often called a marginal abatement cost curve, or MAFTA curve. It essentially ranks different options for reducing greenhouse gas emissions from the cheapest to the most expensive, showing the cost per ton of CO2 equivalent reduced, TO2SE, for each measure, up to a certain potential volume of reduction.
And what does that kind of curve typically show? What are the cheap options?
It typically highlights that some measures are very low cost, potentially even saving money overall, meaning they have a negative cost. Improving energy efficiency is often the prime example here. Using less energy saves money on fuel bills. Preventing deforestation is also often shown as a very low-cost abatement option.
Okay, efficiency and avoided deforestation are cheap. What about other technologies?
Then you move up the cost curve. Things like certain types of renewable energy, like onshore wind in good locations, switching fuels, or changes in industrial processes might have moderate positive costs. Further up the curve, back when these analyses were done around 2006, you'd find things like biofuels, offshore wind, and solar power generally being more expensive. And technologies like hydrogen vehicles or widespread carbon capture and storage were seen as potentially very expensive in the near term.
But the key idea is that those costs for things like solar and wind aren't fixed, right? They're expected to come down.
Precisely. That's the critical role of innovation and deployment. The conceptual curve illustrates how the costs for many of these technologies are expected to shift downwards over time, maybe by 2020 or 2040 in the examples given, as we gain experience, improve designs, and scale up manufacturing. Accelerating that downward cost trend through policy support is seen as absolutely crucial.
You mentioned carbon capture and storage, CCS. Is that seen as having a particular role, especially given our reliance on fossil fuels?
Yes, CCS technologies are specifically highlighted in the sources as having a potentially significant advantage. If they can be deployed safely and economically at scale, they could potentially allow the continued use of fossil fuels, especially coal and natural gas for power generation or industrial processes, which many projections showed still being a large part of the energy mix by 2050, while still making the deep emissions cuts needed.
How does CCS work, basically?
It generally involves 3 steps. capturing the CO2 produced at large point sources like power plants or factories before it reaches the atmosphere, transporting the captured CO2, usually via pipelines, and then storing it securely deep underground in suitable geological formations, like depleted oil and gas fields or deep saline aquifers. It's technically complex and still faces cost and long-term storage security challenges.
Given that climate change is global and technologies are often developed and deployed globally, international cooperation on innovation must be vital.
Absolutely essential. The sources stress this point. Knowledge and benefits from innovation spill across borders, and creating large global markets helps drive down costs for everyone. So international cooperation is needed.
What forms could that cooperation take?
Various forms are mentioned as valuable. Formal multilateral frameworks and agreements, joint funding arrangements for large, high-risk R&D projects, and also more informal arrangements like international research networks and partnerships.
And is it just cooperation between developed countries?
No, the sources specifically emphasize the need to actively involve scientists and engineers from developing countries in these global R&D efforts. They recognize the rapidly growing scientific and engineering expertise in major developing nations like China and India, who are graduating huge numbers of skilled professionals. Tapping into that global talent pool is crucial.
Could dedicated international programs really help accelerate key breakthrough technologies?
The sources suggest they could play a very significant role. Dedicated international programs could potentially set shared research priorities, pool resources, and share the costs and risks associated with accelerating the development and deployment of key technologies. Maybe things like vastly improved solar power, advanced batteries, sustainable biofuels, or building the infrastructure needed for a hydrogen economy.
Are there any cost estimates for such programs?
They provide a very illustrative estimate, just to give a sense of scale. An ambitious international program focused just on deploying cleaner electricity generation technologies might cost something in the order of $6 to $10 billion per year for, say, 20 years. This could support the initial deployment of maybe 1 to 2 gigawatts of clean electricity production per year, helping to drive down costs through learning.
Okay, so innovation is key and needs support. Beyond direct technology support, what are the main policy instruments discussed in the sources to actually drive these emission reductions across the economy?
The sources consistently emphasize that creating an explicit price for carbon emissions is fundamental. It's seen as the most efficient way to ensure that the cost of emitting greenhouse gases, the damage they cause, is factored into economic decisions.
How does pricing carbon help? What's the mechanism?
The idea is to internalize the externality. Climate change damage is an external cost. The polluter doesn't automatically pay for the harm their emissions cause. Putting a price on carbon forces businesses and consumers to face that cost. The price signal should ideally reflect the social cost of carbon, the estimated economic damage caused by emitting 1 additional ton of CO2 over its lifetime in the atmosphere. This price provides a direct financial incentive to find the cheapest ways to reduce emissions.
How can governments actually put a price on carbon? What are the main ways?
There are 3 main approaches discussed. Directly taxing carbon emissions, carbon tax, setting up emissions trading systems, also known as cap and trade, or using regulations that don't set an explicit price but create an implicit cost for emitting.
For any of these pricing policies to work well, what are the key characteristics they need to have?
Credibility, flexibility, and predictability are highlighted as absolutely vital for effective policy design. Businesses and individuals need to have confidence that the carbon price signal is real, that it will persist over the long term, and ideally that it will rise predictably over time. This is essential to encourage the large, long-lived investments needed in low-carbon technologies and infrastructure. Uncertainty about future policy kills investment.
Let's talk about emissions trading systems, like the big one in the EU. How do they work in principle?
Emissions trading schemes, like the EU ETS, operate on a cap-and-trade principle. First, a government sets an overall cap, or limit, on the total amount of emissions allowed from a specific group of emitters, for example, power stations and heavy industry. Then, allowances permits to emit a certain amount, usually 1 ton of CO2e, are issued or optioned off up to the level of the cap.
And companies can buy and sell these allowances.
Exactly. Companies that can reduce their emissions cheaply can do so and sell their surplus allowances to companies that find it more expensive to cut emissions. This trading creates a market price for carbon allowances, which acts as the carbon price signal. Theoretically, it ensures the emissions cap is met at the lowest overall cost to the economy, as reductions happen where they are cheapest.
What are some of the key design issues with trading schemes?
There are many important details. How the initial cap is set. Is it ambitious enough? How deep and liquid the market for allowances is. Are there enough buyers and sellers for efficient trading? And a really critical one is how the allowances are initially allocated. Are they giving away for free to existing industries, or are they auctioned off by the government?
What's the debate around free allocation versus auctioning?
Free allocation can help manage the transition for energy-intensive industries, reducing their initial cost burden and potentially addressing concerns about competitiveness if neighbors don't have similar policies. However, giving valuable allowances away for free can also lead to windfall profits for companies, especially if they can still pass on the perceived cost of carbon to their customers in product prices. It can also impact companies' balance sheets and potentially distort investment decisions compared to auctioning, where companies have to pay for all their emissions.
Do the sources say much about whether carbon pricing really hurts industrial competitiveness or leads to carbon leakage industries moving elsewhere?
They do touch on this. While concerns about competitiveness and carbon leakage are real, the sources generally suggest that, based on experience up to that point, environmental policies overall have not typically been a major determinant of where companies decide to locate their plants or of major shifts in international trade patterns. This seems particularly true if policies are harmonized within large regional blocs like the EU, where competitors face similar standards. But it remains a key political and design challenge, especially for globally traded, energy-intensive goods.
Okay, so pricing carbon through taxes or trading is one major approach. What about the role of regulation?
Regulatory approaches are also discussed as important and often complementary policy instruments. While they might not create an explicit market-wide price for carbon in the same way, regulations implicitly place a value on reducing emissions by setting specific requirements or standards. They can also be particularly effective at addressing certain market failures where pricing alone might not be enough, like overcoming information barriers or ensuring baseline levels of performance.
What kind of regulations are highlighted as being particularly useful for climate mitigation?
Performance standards are highlighted as a particularly effective and widely used regulatory tool.
Performance standards. How do they work? What do they regulate?
Performance standards set specific requirements for the environmental performance of products, equipment, or activities, but crucially, they usually do so without dictating the specific technology that must be used to meet the standard. Examples include minimum energy efficiency standards for appliances like refrigerators or air conditioners, fuel economy standards for vehicles like miles per gallon or grams of CO2 per kilometer, or energy performance requirements for new buildings.
So they set the outcome needed, but let manufacturers figure out the best way to achieve it.
Exactly. This technology neutrality allows for flexibility and encourages innovation. By setting progressively tighter standards over time, governments can effectively remove the least efficient products from the market, improve the average efficiency of the stock, and provide a clear signal to manufacturers to innovate and develop even better performing products to meet future requirements.
Are there examples where standards have been shown to work well?
Yes, the sources point to examples like the long-running U.S. Federal Energy Efficiency Standards Program for appliances and various state-level building energy codes, particularly in places like California, Massachusetts, and Colorado, as well as efforts in the U.K. These have demonstrably achieved significant energy savings over time. China is also mentioned as increasingly using regulation, alongside other policies, to drive energy efficiency improvements, especially in its large state-owned industrial enterprises. So, pulling the mitigation piece together, it's about driving those deep emissions cuts across all the major sectors: power, transport, buildings, industry, agriculture, and land use. The key tools discussed are putting a price on carbon through taxes or trading, using smart regulation like performance standards, and fundamentally underpinning all of this with strong support for rapid technological innovation and international cooperation to make it all feasible and cost-effective globally.
That's a comprehensive picture of the mitigation side. But, as we established early on, some level of climate change is already locked in due to past emissions, and more is likely unavoidable even with strong mitigation. That brings us squarely to the other pillar: adaptation. How do we live with the changes we can no longer prevent?
Adaptation is indeed the other absolutely essential part of the policy response outlined in these sources. It's defined broadly as actions taken to reduce the negative impacts of the climate change that does occur. And importantly, it can also involve actions to take advantage of any potential beneficial opportunities that might arise in specific regions from a changing climate, though the sources emphasize the negatives far outweigh the positives overall.
But it's crucial to be clear. Adaptation doesn't stop climate change itself, does it?
No, that's a critical distinction the sources make repeatedly. Adaptation is about managing the consequences, not preventing the cause. In fact, the economic cost of undertaking adaptation measures is in itself presented as part of the total cost that climate change imposes on society. It's a cost incurred because of climate change.
And how are the costs of adaptation expected to evolve as the climate changes more?
The sources emphasize that as global temperatures rise higher, the cost required for effective adaptation will rise sharply. Furthermore, even with significant investment in adaptation, there will likely be substantial residual damages impacts that adaptation simply cannot prevent or fully cope with, especially at higher levels of warming. There are limits to adaptation.
Are there any estimates given for the scale of adaptation costs, particularly for developed countries?
Yes, there are some broad estimates. The additional annual cost just for developed countries to make their new infrastructure and buildings resilient to projected future climate changes, things like stronger storms, higher temperatures, changing water patterns, could range quite widely, somewhere between $15 billion and $150 billion each year.
$15 to $150 billion annually. How does that compare to their economies?
That range represents about 0.05% up to 0.5% of the GDP of developed countries. And again, these costs are expected to increase sharply as temperatures rise further, and this doesn't necessarily cover the costs of retrofitting existing vulnerable infrastructure, which could be much higher.
Can you give some concrete examples of the kinds of adaptation investments needed that drive these costs?
Sure. The sources mention significant investments needed in managing increasing water stress and potential water shortages in many regions. For example, one estimate suggested the UK might need to increase its reservoir capacity by 10–15% just to cope with projected changes in rainfall patterns, at a potential cost around $5.5 billion. Another major area is strengthening flood defenses, especially in coastal areas facing sea level rise and potentially stronger storms. An estimate mentioned for upgrading the defenses around a vulnerable city like New Orleans to withstand a Category 5 hurricane was around $32 billion.
Those are substantial sums. Now, who is likely to be most affected by climate impacts and therefore most in need of adaptation support?
The sources are absolutely clear and consistent on this point. The poorest countries and the poorest people within all societies have the least capacity to adapt on their own.
Why is their capacity so much lower?
It's primarily due to severe resource constraints. They often lack the necessary financial resources, the technical expertise, the institutional capacity, and the stable governance needed to plan, fund, and implement effective adaptation measures. Ironically, the greatest need for adaptation will likely be in low-income countries, particularly in regions like sub-Saharan Africa and South Asia, which are often projected to face some of the most severe physical impacts.
And does this disparity in capacity and need imply a responsibility for richer countries to provide support?
It absolutely does, and the sources make this argument strongly. There's a clear ethical and practical case presented for significant financial and technical transfers from rich countries to poor countries, specifically to support adaptation efforts.
What's the basis for that argument?
It's reinforced by the issue of historical responsibility. Developed countries are responsible for the vast majority of the accumulated greenhouse gas emissions currently in the atmosphere that are driving climate change. Poorer countries, which contributed very little to the historical problem, are often suffering and projected to suffer disproportionately from the consequences. So, there's a strong equity argument for the historical emitters to help the victims adapt.
Can markets play any role in driving adaptation, or is it all down to government and international support?
Markets can play a role, yes, particularly in stimulating what's often called autonomous adaptation. These are the actions taken spontaneously by individuals or private businesses in response to observed or expected changes in climate, often driven by market signals.
Where is market-driven adaptation most likely to happen?
It's particularly relevant in sectors where climate is a direct input or risk factor, like agriculture, farmers changing crops or planting dates, forestry, water-dependent industries, and energy production. Insurance is also highlighted as an important market mechanism. By pricing climate-related risks, like flood or storm risk, insurance markets can, in theory, send signals that incentivize risk reduction behaviors, for example, discouraging new construction in high-risk areas or influencing property prices to reflect vulnerability.
But are markets sufficient on their own to deliver all the adaptation that's needed?
No, the sources state quite clearly that markets alone are unlikely to deliver the full required adaptation response. They are necessary, but not sufficient. This is largely due to persistent market failures.
What are the key market failures that hinder adaptation?
One major failure is inadequate information. Future climate change impacts are often uncertain, especially at the local level where adaptation decisions need to be made. Individuals and businesses frequently lack the detailed, reliable, localized climate projections and impact information needed to make informed, optimal adaptation investments. Another key issue is positive externalities.
Positive externalities, meaning the benefits of adaptation spill over.
Yes. Many adaptation measures, like building a seawall, restoring a wetland for flood control, or developing drought-resistant crop varieties, generate benefits that extend beyond the individual or entity making the investment. They benefit the wider community. Because the private return is lower than the social return, individuals or firms tend to underinvest in these types of measures from society's perspective.
So if markets alone aren't enough, governments need to step in to facilitate and support adaptation.
Absolutely. Governments have a crucial role to play. Firstly, in providing essential climate information and projections, which can often be considered a public good. This includes things like improved regional climate models, detailed forecasts of rainfall and storm patterns, local-level economic impact assessments, and granular flood or drought hazard maps. This information helps individuals and markets make better decisions.
And beyond providing information.
Governments also need to provide an appropriate regulatory framework, for example, updating building codes or land use planning rules to account for future climate risks. They also need to undertake strategic public investments in large-scale adaptation infrastructure, like major flood defenses, where the benefits are widespread, and potentially directly support adaptation measures, particularly for vulnerable groups or sectors where market incentives are weak.
How well are countries actually doing on adaptation? Are developed countries with more resources leading the way?
Interestingly, despite having more resources and generally well-developed market structures, the sources noted that adaptation planning and implementation was still at a relatively early stage, even in most developed countries at the time the material was written. While many had conducted assessments of potential impacts and vulnerabilities, only a limited number were reported to be moving towards implementing concrete, widespread adaptation initiatives across their economies. There seemed to be a gap between assessment and action.
What about integrating adaptation into broader development efforts, particularly in developing countries where resources are scarce? Is that seen as important?
Yes, this is strongly emphasized. There's a call for both international donors and national governments in developing countries to systematically integrate or mainstream adaptation considerations into all their existing development budgets, plans, and programs. The idea is that climate resilience shouldn't be a separate add-on. It needs to be built into everything from agricultural policy to infrastructure planning to health system investments.
Is there evidence that existing development aid is vulnerable to climate change?
Yes, an analysis cited looked at official development assistance, ODA, government aid flows, and found that a significant portion of this aid is directed towards activities and sectors that are potentially highly vulnerable to climate risks. One figure illustrated this, showing estimates that perhaps 50–65% of total aid going to Nepal could be affected by climate risks, and maybe 12–26% in Tanzania.
So if development projects don't account for climate change, the aid money could be wasted or the projects could fail.
That's precisely the risk. It means development projects like irrigation schemes, roads, health clinics need to be designed and located considering future climate conditions from the very beginning to ensure they are effective and sustainable.
How should funding for adaptation be channeled? Should it be separate funds or integrated into existing budgets?
The sources suggest that while dedicated international funds specifically for adaptation exist and can play a role, there's a potential risk that they can hinder this crucial mainstreaming process. Relying solely on separate funds might keep adaptation siloed. The argument presented is that, ideally, additional funding provided for adaptation should be integrated into countries' normal national budgetary processes and allocated through their existing national development plans to ensure it's used efficiently and effectively across all relevant sectors, rather than being managed as a standalone issue. So adaptation is fundamentally about building resilience, managing unavoidable impacts. It requires significant investment, especially for the most vulnerable. It needs to be mainstreamed into all development thinking, supported by governments providing crucial information and frameworks, and there's a strong case made for substantial financial support flowing from developed to developing nations to make it happen.
Okay, let's circle back briefly to land use change, specifically deforestation. The sources really hammered home that this is not just an environmental issue, but a huge piece of the emissions puzzle and potentially a very cost-effective way to mitigate climate change.
It really is presented as both a major problem and a major opportunity. As we mentioned, land use change, with deforestation being the dominant factor, was estimated to account for a massive 41% of total global greenhouse gas emissions back in 2000, according to one source figure. That makes it the single largest net source of emissions among the land use categories analyzed there.
41%. That's huge. And you said it's identified as a low-cost way to cut emissions.
Yes, that's the crucial opportunity highlighted. Compared to many technological options for reducing emissions in the energy or industrial sectors, avoided deforestation is consistently identified in the sources as one of the most low-cost abatement opportunities available globally.
How low cost are we talking?
The estimates cited suggest the cost of avoiding 1 ton of CO2 emissions by preventing deforestation could be under $5 per ton, perhaps even as little as $1 per ton in some specific contexts, or using certain assumptions. That makes it significantly cheaper than many other mitigation options, at least for a substantial volume of potential reductions.
So, if it's such a cheap way to make a big dent in emissions, why is stopping deforestation proving so difficult in practice?
It faces really significant and complex challenges on the ground. The sources point to several key barriers. These often include weak institutional capacity in the countries where deforestation is most rampant. Government agencies might lack the resources or authority to manage forests effectively. There are often widespread governance issues, including corruption and a lack of effective law enforcement to prevent illegal logging and land clearing.
And powerful interests who benefit from deforestation.
Absolutely. Deeply entrenched vested interests ranging from large corporations involved in logging, mining, or agriculture to local elites often benefit economically from continued deforestation and resist efforts to stop it. Monitoring vast, remote forest areas is also inherently difficult, although the sources do note that advances in satellite-based remote sensing technology are making it easier to track deforestation patterns in near real time.
So it's not just about finding the money to pay people not to cut down trees. It's fundamentally a governance, enforcement, and political economy problem in many places.
It is, to a large extent. The sources emphasize that simply trying to fence off forests or ban activities often isn't enough. Successfully tackling deforestation requires changing the underlying economic incentives that drive it. It means encouraging alternative, sustainable economic activities that provide livelihoods for local populations without requiring forest clearing.
And poverty is often a key driver, isn't it?
Yeah. Yes, poverty is frequently identified as a key underlying driver. In many regions, poor rural populations rely on clearing forests for subsistence agriculture, fuel wood, or small-scale logging simply because they lack other viable economic options. Addressing deforestation effectively, therefore, requires carefully considering the interests and livelihoods of the people who currently depend on converting forest land and actively working to provide them with sustainable alternatives.
Is there an example of how providing alternatives can work?
Yes, the sources provide an interesting example from the Philippines. A program focused on intensifying rice production on existing lowland farms successfully provided alternative employment opportunities for people who previously lived in and cleared upland forest areas. This intervention reportedly halved the rate of forest clearance by those upland populations, demonstrating how linking agricultural development with forest conservation can be effective.
That really highlights the need for integrated approaches, connecting conservation with development.
Exactly. The sources argue that simply designating protected areas, while important, isn't sufficient on its own. For protected areas to be truly successful in halting deforestation in the long run, they need to be integrated into broader landscape-level natural resource management programs that address the economic and social drivers of forest loss happening outside the protected boundaries.
Are there ways to use forests for timber production more sustainably?
Yes. The sources also mention that adopting sustainable forest management practices, including methods known as reduced impact logging, RIL, can help minimize the damage caused by timber harvesting and preserve more of the forest's carbon stocks and biodiversity compared to conventional logging methods.
And what about agricultural land that's already cleared? Can practices there help reduce emissions too?
Yes, definitely. Changes in how agricultural land is managed can also provide significant savings in both CO2 and non-CO2 emissions. Practices like adopting conservation tillage, reducing or eliminating plowing help keep carbon stored in the soil. Stopping the common practice of burning crop residues after harvest avoids releasing CO2 and other pollutants. The IPCC, as cited in the sources, estimated that there's significant potential to reduce emissions from agriculture through such practices at relatively modest costs, for example, potentially avoiding 1 to 2 gigatons megatons of CO2 equivalent emissions globally at costs up to around $27 per ton by 2020. So, yes, addressing emissions from land use change, especially deforestation, is presented as a vital and potentially very cost-effective part of the overall climate mitigation puzzle. But its success hinges critically on tackling those complex social, economic, and governance challenges on the ground and on providing viable, sustainable livelihoods for the communities involved.
It really underscores how intertwined environmental protection is with issues of poverty, development, and governance. Okay, let's zoom out now to the biggest picture, the ultimate challenge: international collective action. The sources frame climate change fundamentally as a global public good problem, right?
That is the absolute core challenge from an international relations and economic perspective. The Earth's climate system, specifically its capacity to absorb greenhouse gases without triggering dangerous levels of warming, is a classic global public good. Everyone on the planet benefits from a stable climate, regardless of whether their own country makes efforts to reduce emissions or not.
And that leads directly to the free rider problem.
Exactly. Because the benefits of mitigation are shared globally, while the costs of cutting emissions are primarily borne domestically, individual countries have a rational economic incentive to minimize their own efforts and hope to free ride on the emission reduction efforts undertaken by other countries. If everyone acts purely on this narrow self-interest, the collective result is far too little action globally to solve the problem.
And complicating things further, there's no single global government or authority with the power to force countries to act against their perceived short-term interests.
Precisely. There is no world government with the legal mandate, the enforcement capacity, or even the universally accepted moral authority to manage the shared global climate resource effectively. Therefore, achieving action on the massive scale required relies almost entirely on voluntary, sustained, and highly coordinated international cooperation among sovereign nations. And that kind of cooperation is inherently difficult to achieve and maintain, especially given the free rider incentive and the vastly different circumstances and priorities of nations.
What are the main existing international frameworks discussed in the sources that try to facilitate this cooperation?
The key overarching framework mentioned is the United Nations Framework Convention on Climate Change, the UNFCCC. This was agreed way back at the Rio Earth Summit in 1992. Its ultimate objective, as stated in the convention, is to stabilize greenhouse gas concentrations in the atmosphere at a level that would prevent dangerous anthropogenic interference with the climate system.
Does the UNFCCC set binding targets?
No, the Framework Convention itself doesn't set binding emission targets for countries, but it does establish some crucial foundational principles for international cooperation. Notably, it enshrines the principle that countries should act consistently with their common but differentiated responsibilities and respective capabilities. It also states that developed countries should take the lead in combating climate change and its adverse effects, given their greater historical contribution to the problem and their greater capacity to act.
So common but differentiated responsibilities is a key principle. Was the Kyoto Protocol the first major attempt under the UNFCCC to put binding limits in place for some countries?
Yes, exactly. The Kyoto Protocol, which was agreed in 1997 and finally entered into force in 2005, was negotiated under the umbrella of the UNFCCC. It represented the first attempt to establish legally binding emission reduction commitments, but only for a specific list of developed countries, known as Annex I countries, for the first commitment period running up to 2012.
Did Kyoto also set up mechanisms for things like emissions trading?
Yes, it did. Kyoto established several innovative mechanisms intended to provide flexibility and reduce the costs of meeting the targets. These included international emissions trading between countries with targets, and project-based mechanisms like the Clean Development Mechanism, CDM, and Joint Implementation, JI, which allowed developed countries to invest in emission reduction projects in developing countries or other developed countries and get credit towards their own targets.
But Kyoto faced significant challenges, didn't it, in terms of participation?
It did. The sources note its limitations. Most significantly, the world's largest emitter at the time, the United States, signed the protocol but never ratified it, meaning it wasn't legally bound by a target. Australia also initially opted out. And even among countries that did ratify and take on targets, some, like Canada, subsequently indicated they would struggle to meet their commitments. Developing countries, including major emerging economies like China and India, did not have binding emission targets under Kyoto's first period, consistent with the principle of differentiated responsibilities.
So, while groundbreaking in establishing binding targets and mechanisms, Kyoto ultimately only covered a fraction of global emissions and face major participation hurdles from key players. Has climate change become more central in other international discussions since then?
Yes, the sources indicate it has become increasingly central to broader international economic and political relations. It's regularly discussed at major forums like the G8 summits, now G7, alongside core issues like global economic growth, trade, development aid, and energy security. The sources specifically mention G8 leaders agreeing to an action plan on climate change and energy at their Gleneagles summit in 2005, and further exploring the crucial links between climate change policy and energy security at the St. Petersburg summit in 2006. It's moved from being seen as a purely environmental issue to a core economic and security concern.
Looking forward from the time these sources were written, what do they suggest is essential for future international frameworks to be more effective in driving the scale of global action that's actually needed?
A crucial element identified is the need for a clear, shared understanding and ideally agreement on the long-term goals for stabilizing the climate system. Having a common target, like aiming for stabilization within that 450-550 ppm CO2e range, or potentially a temperature goal like limiting warming to 2 degrees C or 1.5 degrees C, which gain prominence later, is seen as essential to provide a clear direction for national policies, international negotiations, and long-term investment signals.
And these goals shouldn't be set in stone forever.
No. The sources emphasize that these long-term goals need to be regularly reviewed and potentially revised based on the latest scientific findings about climate impacts and risks and updated economic analysis of the costs and benefits of action. The Intergovernmental Panel on Climate Change, IPCC, is highlighted as playing a vital role in providing these regular, comprehensive assessments of the science and economics to inform policymakers.
We talked earlier about the efficiency benefits of having a global carbon price. How critical is that for effective international action?
Achieving economic efficiency on a global scale, making sure emission reductions happen wherever in the world they are cheapest, ideally requires having a broadly similar price placed on carbon emissions across different countries and sectors. Creating this transparent, comparable, and ideally rising global carbon price signal is presented as an urgent and central challenge for international cooperation.
But achieving that is difficult in practice.
Very difficult. Options like internationally harmonized carbon taxes across all major economies or creating a truly integrated global emissions trading system are acknowledged to be extremely complex politically and institutionally to negotiate and implement effectively. Linking different regional or national trading schemes is seen as a more practical, albeit still challenging, step in that direction.
Beyond efficiency, how do you ensure the whole effort feels fair enough for countries to buy into it and sustain cooperation over the long term? That equity question seems key.
Absolutely. Securing broad-based participation and sustained cooperation over decades requires a distribution of effort that is perceived as equitable or fair among nations. The sources explicitly state this. And they note that various ways of calculating a fair share of the burden, whether based on current income levels, current emissions per capita, or historical responsibility for past emissions, all tend to point towards developed countries needing to take responsibility for making the largest emission reductions.
Are there numbers put on that? What kind of cuts might developed countries need to make?
Based on the stabilization goals discussed, estimates cited suggest that developed nations collectively might need to reduce their emissions by at least 60%, perhaps even 80% or more, from their 1990 levels by the year 2050. This deep cut by developed countries is seen as necessary to create the atmospheric space for emissions in developing countries to grow for a period as they pursue essential economic development before they too eventually need to transition to low-carbon pathways, all while keeping global emissions within the budget required for stabilization.
So that UNFCCC principle of common but differentiated responsibilities and respective capabilities remains absolutely central for designing future international agreements.
Yes, it's seen as the cornerstone for achieving equity and broad participation. Future international frameworks, the sources argue, need to effectively translate this principle into practice. This likely means moving beyond a simple binary division between developed and developing countries, and instead using a wider range of commitments and multi-stage approaches that better reflect the diverse circumstances, capabilities, development needs, and historical contributions of different countries and groups of countries. It needs to be more nuanced than the initial Kyoto structure.
What about those international sectors we mentioned, aviation and shipping? They operate largely outside national borders. How should their emissions be tackled?
The sources explicitly identify international aviation and maritime shipping as significant and rapidly growing sources of emissions that fall outside the scope of national targets under frameworks like Kyoto. They state clearly that carbon pricing mechanisms and other regulatory measures need to be extended to cover these international sectors through specific international agreements, likely negotiated through the relevant UN bodies like the International Civil Aviation Organization, ICAO, and the International Maritime Organization, IMO.
Can international cooperation help accelerate the clean energy transition in developing countries in ways beyond just providing funding for adaptation?
Yes, definitely. International cooperation can play a crucial role in improving the overall enabling environment for private and public investment in clean energy and sustainable development within developing countries.
What did that involve?
It includes things like providing technical assistance to help developing countries design effective domestic climate policies, helping remove domestic barriers to clean investment, like reforming energy subsidies or improving grid infrastructure, and actively facilitating the transfer and deployment of low-carbon technologies from developed to developing countries. Importantly, domestic policy reforms within developing countries themselves are also key. The sources mention China's example, where energy pricing reforms and regulatory targets contributed significantly to a sustained fall in the energy intensity of its economy, demonstrating the power of domestic action, which also supports international efforts.
And finally, should future efforts build on what was learned from Kyoto or start fresh?
The strong suggestion is to build on and learn from the experience gained under existing mechanisms, particularly the institutions and market infrastructure established under the Kyoto Protocol for International Emissions Trading and Project-Based Crediting. While imperfect, these provided valuable lessons. Developing future international carbon markets will likely involve linking and expanding existing regional, national, or sectoral emissions trading schemes, which requires greater international cooperation and the development of robust new institutional arrangements to ensure compatibility, transparency, and trust between different systems. So, wrapping up the international action piece, the global nature of climate change fundamentally demands voluntary but highly coordinated international action. Success hinges on agreeing on shared long-term goals, finding an equitable way to distribute the effort that reflects differentiated responsibilities and capabilities, and building robust cooperative mechanisms. These mechanisms need to effectively price carbon globally, accelerate technology development and transfer, provide substantial support for adaptation in vulnerable nations, and address emissions from all major sources, including international transport. It remains an incredibly complex diplomatic, economic, and political challenge on a truly global scale.
It really is a monumental undertaking, as these sources make abundantly clear. There's no single easy answer presented here.
No, definitely not. It's multifaceted and challenging on every level.
So let's try to pull the threads together from this deep dive. What's the overall picture that emerges from the sources we've explored?
Well, first, the science presented is robust and points unequivocally towards rapid human-caused warming. This warming carries with it the potential for severe, widespread, and in some cases, potentially irreversible impacts on both human societies and natural ecosystems. And a crucial point is that these impacts are projected to fall disproportionately, most acutely, on the world's poorest people and the most vulnerable ecosystems who did the least to cause the problem.
And second, the economic analysis, particularly highlighted by the Stern Review, provides a really powerful counterpoint to the idea that climate action is too expensive.
Exactly. The economic case presented is that the long-term costs and risks of inaction, of letting climate change continue unchecked along a business-as-usual path, are likely to be far, far greater than the manageable costs of taking strong, prompt action now to transition to a low-carbon global economy. Mitigation is framed not as a burden, but as a highly productive investment in future prosperity and resilience.
Okay, so the science demands action, the economics justifies it. What about how to actually do it? The policy response needs to be multifaceted.
Absolutely. It requires tackling the problem from multiple angles simultaneously. This includes deep cuts in greenhouse gas emissions across all major sectors. That's mitigation driven by a combination of key policy levers. These include putting a price on carbon pollution through taxes or emissions trading, implementing smart regulations like energy efficiency standards, and crucially, fostering rapid technological innovation and deployment, supported by strategic public and private investment in R&D and market creation.
And mitigation alone isn't enough, right? Adaptation is the other essential piece.
Yes. Adaptation is critical for coping with the unavoidable impacts that are already locked in due to past emissions and will continue to intensify for some time. This requires significant investment in building resilience, things like stronger infrastructure, better water management, climate-resilient agriculture. It also means systematically integrating climate risk assessment into all development planning and activities, and providing substantial support, including financial and technical assistance, to help the most vulnerable countries and communities adapt, recognizing the equity dimensions involved.
And woven through all of this is that deeper ethical dimension that one of the sources brought to the forefront.
Right. It suggests that truly addressing the root causes might require more than just policy and technology. It may involve a fundamental shift in perspective, moving beyond a purely human-centered, anthropocentric view, and a relentless focus on maximizing short-term economic growth and material consumption, often at the expense of the natural world. It highlights the profound ethical responsibility we arguably have towards the health of the planet and, crucially, towards the welfare of future generations who will inherit the consequences of our choices today.
And finally, the inescapable reality.
Mm-hmm.
Because greenhouse gases mix globally, affecting everyone, and the impacts are widespread, effective action absolutely must be international.
It has to be. Success hinges on building and sustaining robust international cooperation, despite all the inherent challenges like the free rider problem and vastly different national circumstances. This requires establishing shared long-term goals, agreeing on an equitable distribution of the effort involved, reflecting those common but differentiated responsibilities, and creating effective international mechanisms to coordinate policies, mobilize finance, share technologies, and ensure transparency and accountability.
So it's a global problem demanding a truly global solution, built on a foundation of solid science, compelling economics, complex policy interventions, and potentially a challenging but necessary shift in our underlying values and our capacity for international cooperation. It's a massive transformation needed really across every sector, every country, and perhaps even within ourselves.
That sums it up well. It is indeed a challenge of enormous scale and complexity, as laid out in these sources. And when you really consider the potential long-term impacts described, the sheer scale of the transformation required, and then factor in that ethical call from some economists and philosophers to genuinely value the welfare of future generations on par with our own. Well, it certainly puts the decisions we make today, collectively and individually, into a very stark and urgent perspective.
It really does. It makes you wonder, doesn't it? Given all the immense complexities and challenges that these sources outline, the powerful inertia of the current system, the persistent free rider problem in international relations, the difficulties in achieving global governance, the need for trillions in investment, the required shifts in deeply ingrained consumption patterns, what specific kind of breakthrough, whether it's technological or a new policy design, or perhaps a shift in international norms or relations, could truly unlock the scale of cooperation and accelerate the transition fast enough to realistically avoid the most dangerous climate risks that these sources warn us about? What catalyst could actually make nations and people globally move together decisively and sustain that action on something this huge and long-term?
That is indeed the profound and enduring question that hangs in the air after digging into this material. What will it take?
Something for all of you to perhaps mull over as you reflect on this deep dive. Thanks for joining us. Until next time.